This is it, ladies and gentlemen. This is the last set of notes for Algebra 1. Soak it in for a minute. Take a moment to reflect. I shouldn't say that. I was going to say this is the last distance learning assignment that you'll do, but who knows what's coming in the fall, right? But the last distance learning assignment for me, right? So yeah, hopefully you'll come and visit in the fall whenever we do get back. Stop and say hi. A lot of you'll probably go you're walking down the hall, you either turn right to my room or left to Mrs. Wolf's room. You'll probably just be like walking down, you'll just turn left to Mrs. Wolf's room rather than turning right to go to my room. So, I mean, I'll probably be standing there, with Mrs. Wolf saying hi to everybody. So don't act like you don't know me. Okay. All right. But again, this is the last assignment. Finish strong. All right. So we're going to be looking at the distance formula. Last assignment was the midpoint formula, and this is the distance formula. We're working with, again, segments, two coordinate points. Okay. We figured out a way to find the location of the midpoint, and now we're going to be figuring out a way to find the length of the segment, how to find the distance from one point to the next. Okay. And it's all derived from really the Pythagorean theorem. If you've ever learned the Pythagorean theorem before, and you will learn that next year in geometry as well. But it's all really based around the Pythagorean theorem. Okay, but we have the distance formula here. The distance formula is used to calculate the distance between 2 points in a coordinate plane. So it's got to be graphed. So remember that at any 2 points, say you've got points A and B out there in space, right? And you've got coordinate A as something x comma y, and you've got coordinate B out there x comma y. You're basically going to find the distance between those two coordinates, how much space is between those two coordinates. Now, how do we find that? Well, what we do is we take the difference of the x coordinates squared. Remember, distance means subtraction. We find the difference in the x coordinates squared plus the difference in the y coordinates squared. Now, to tell them apart, we put little ones and twos, just like we did at the midpoint formula. So we're going to say x2 minus x1 squared plus y2 minus y1 squared. And we're going to find the sum of those two things, right? It's plus. And then what we do is we take the square root of that, and that will get you the distance between any 2 points. Okay, so let's practice that. Again, with any formula that we need to memorize, you're not going to need to memorize this right now, but maybe in geometry, we should write it out. We got x2 minus x1 squared plus y2 minus y1 squared. Difference in the x's squared plus difference in the y's squared, and we take the square root of it. So let's figure out what our x's and y's are. So let's call this point A and call this point B. Find the coordinate here. This looks like it's 3, 5. And point B looks like it's at 4, -4. Okay, now it doesn't matter which one you call x1, y2, x1, x2, y1, y2. It doesn't really matter. But make sure you keep track. So I like to call one point A and one point B, and just go from there. So that means my x2 is going to be 4. My x1 is going to be 3. And that's right here, right? x2, x1, y2, y1. So we've got -4 minus 5. Okay, so now let's put that together. We got 4 minus 3 is 1. -4 minus 5 is -9. Now watch out. Make sure you're putting that in parentheses here when you put that into your calculator. I'm going to show it on my big calculator. You guys don't have this big calculator, but I want to emphasize you using parentheses when you square that negative, because that always throws people off. Picture me in front of you screaming at you. Don't forget to put the parentheses. So we got this. Let's just do this. Let's go 1 squared plus, and then here's where I have to do my parentheses, -9 squared. Don't forget parentheses. So we got the square root of 82. and then it says round to the nearest tenth. You know what we could make you do? We could make you do this whole factor tree thing and put that into simplest radical form, but I don't need you to do that. So we do the square root of 82. Your geometry teachers, man, but we're not actually sure how they teach it. But for right now, we're just going to run to the nearest tenth. 9.1, it looks like it's going to be 9.1. That's the distance, 9.1 units. Okay. Here's number B, or letter B, excuse me. Let's call this point A and call this point B. Point A has coordinates at -3, 3. And point B has coordinates 2, 2. Okay, so we're going to find the distance between. So 2 minus a -3. Watch out for that. That's minus -3. 2 minus +3. Squared. Okay, so that will give me, remember this turns into a big plus sign. 2 plus 3 is 5. 2 minus 3 is -1. So this gives me square root of 25 and 1. So the square root of 26, which is a not perfect square. So the square root of 26 is 5.2, maybe 5.1. 5.1. There's my answer. Okay. Given the 2 points here, we've got -5 minus 0, x minus x squared, plus y minus y. Don't forget the negatives in the parentheses. Okay, so this gives me a -5 squared plus, now this, -1 plus 2, 1 squared. So this gives me 25 plus 1. Didn't we just do that? Isn't that square root of 26? Which is 5.1, right? We just did that. Look at that, square root of 26. Okay, same answer as the last one. Okay. And the last problem, algebra 1. All right, so the distance is -6 minus -8 squared plus 7 minus 10 squared, which gives me a big plus sign here. -6 plus 8 is 2. And we have a -3 squared. Okay, so which gives me a 4 and a 9, which gives the square root of 13, which I'm going to guess 3.6. Let's say that. 3. Let's see. Let's see what it is. See how close I came. Square root of 13. Booyah. 3.6. There's my answer. All right, for the assignment for this, it's the distance formula worksheet that you have. Just do numbers 1 to 12. I don't know if there's any others than that, but it's just 1 to 12 if there's any other. Okay, and again, you only need to round to the nearest tenth. You do not need to do any simplest radical form. Those of you doing photo math or Googling your answers, they will probably put them in simplest radical form. So it will be very easy to tell if you're cheating. So don't do that. All right. Hope we all have a good summer. Hope we all stay in and stay healthy and get some good relaxation time, and come and see me whenever we get back. If that's the fall, if that's later than that, just come, stop by, say hi. All right, see you folks.